welcome everyone. So this is Good Row, and as usual today we're gonna talk about we're gonna solve some lead code problems. So today we're gonna solve some problems about the linked list. A linked list is a well-known data structure that's used in a lot of cases actually. So today we're gonna solve a lead code problem about the linked list, and the topics are the superheroes. The first is delete the middle node of a linked list, which is gonna help us to eliminate one of the superheroes to continue the battle, and the second is odd and even lists, when which the superheroes gonna balance their abilities to continue their battle. So you can find me on GitHub, or you can find me on LinkedIn, or on Instagram. And recently we created a Discord server, so we can get to know you better. And without further ado, let's go to the linked list. So here I have a Geek for Geeks tutorial that's gonna help us to understand better and use better the linked list. So a linked list is a linear data structure similar to arrays. It's a collection of nodes that are linked to each other, and each node, as you see, is composed of two parts, which are the data, which is the data of this node. It can be a integer, it can be string, it can be anything, and the next, which is a pointer that point to the next node, and this goes on until it find a null, it find anything. So this is the end of the linked list. So to create a linked list, we're gonna use the constructor and self data equal data and self next equal none. This is the head. امين وينك شوكبي؟ انا مضيد عليك. And the other operation is pretty easy. We're gonna iterate through the linked list until we get to the known head. So there is no head, and if we want to insert, then we're gonna insert it. So basically this website is gonna help us to work on the problem, and without further ado, let's go to the problem. So I think it's better to, okay, let's begin with this problem. So let's shrink back our okay, so this open is data. Okay. Okay, so the first problem, you are given the head of a linked list. Delete the middle node and return the head of the modified linked list. The middle node of linked list size is n, and is the n multiplied by 2th node from start using zero-based indexing, where x denote the largest integer less than or equal to x. Okay, so for n equal 5, the middle node are 0, 1, 1, 2, and 2 respectively. Okay, so this is our linked list. 1, 3, 4, 7. So this is the middle. 1, 3, 7, 1, 2. So 1, 3, 4. We're gonna just delete it. Okay. What if length is even? So this is the example of the even length. So we're gonna just delete. I think it's yeah. We have to. So for above figure, represent the given for n equal 4, node 2 with value 3. Oh. So it's gonna just divide by 2 and select it. So n equal 4. I have to. Okay, so I think the last number is gonna divide by 2 and so because this is 0 1 2 3 4 4 I think 0 1 2 3 3 and then 0 1. Okay, I think I have to read it again. So the middle node of a linked list of size n is the nth node from start of 0 base where x. What is this x? Denote the largest integer less or equal than x. So for n, the middle nodes are 1 0 1 1 2 2 1. I didn't understand that. So the one represents the given linked list. The indices of the nodes are written below. Since node 3 will be the value. So this is odd. Yeah, this is odd. So we're fine. We return the new list. Okay. When it's even, the above figure represents the given linked list for node 2 with the value 3. I think we're gonna divide by the. It is not sorted. So it is not sorted. So the middle node of a linked list of size n. Why it has this? The value of this node is always the size. Oh no, this not. I don't really understand this sentence. So okay. So this case is easy, and this. Do you have to make? Why it's not 3? It's like 3, man. Represent the given linked list for n equal 5. I don't really understand what's going on. So this test case since n equals 7. So 1 2 3 4. Oh, so node 3 with value 7 is the middle. So it's gonna count like this: 1 2 3 4 5 6 7. Okay, so 1 2 3 4. So 1 2. Okay, so when he chooses in the middle, he's not gonna start from 0. He's gonna start from 1 2 3 4 5 6 7. Then he's gonna divide by 2, and it's gonna choose the index starting from 0. So as I understand, let's make this that, and let's draw the linked list. So have this 1, this 3, this is 4, 7, 1, 2, and 6. Each one is pointing at the other. I think when it's gonna count, okay, let's make another. When it's gonna count, he's gonna start from 1, 2, 3, 4, 5, 6, and 7. So the size is 7, n equals 7. It's gonna divide it by 2. So it's gonna divide it by 2, it will be 3. It's not a float, it's a int division. And then the indexes will start from 0, so 0, 1, 2, 3, 4, 5, 6. So it's gonna delete this. I think we're good. So is there a function that returns the size or not? Okay, so let's put that away and focus on our mission. Okay, so we have already the head. I think we don't know the size, so I think we don't know the size. So we're gonna iterate through the linked list to know its size, to know the middle. Okay. So I think I'm gonna make a counter, or like size equals 0, and then we'll have to iterate through it. Let's use our side. So is none. It will be a while loop. So position current sound. But if it's only one head, so it's gonna remove this head. If you didn't have function to return size, how would you calculate it? I think I'm gonna iterate through it. I'm gonna iterate until I get to the null node. This is the end. I'm gonna iterate it. So okay. Okay, let's just copy this code. We're not gonna insert it, we're just gonna hint turtle vs robot. Oh, I think this is the slow and fast pointers. Yeah, I think it is. I saw it in a video. I saw it in a video, yeah. But no, let's I'm gonna do the class quit. I'm gonna iterate through it all, and then okay, so we're not gonna insert anything, but if there is only one head, so if self dot next equal, yeah, I saw it in a video actually, but I don't know. I don't want to use it now. Well, not. I don't want to watch the video again, and because we don't have time actually. So let's see. So if self head dot next, I think self dot head dot next. Self dot head dot next equal null. So there is no other node. There is only one node. I think we're gonna delete the delete the head actually. So there is a remove first node. Okay. No. We have to do this. Okay. So this is it. This at the known index we'll have to know our index. So if self dot head is none, okay, if there is no head, and current node equals position equals 0. Now before that we're gonna iterate through it. So I'm gonna use this. I'm gonna use this to iterate through it. So while current node, okay. So I have to put it here. While current node is not known, and okay, I don't need that. So the position, I'm gonna make it size or not. I'm gonna make the position and then I'm gonna make position equal position multiplied by 2. Divided by 2 actually. So so now I think we had the position of it. Okay, so if index equal 0, remove first node. But how we're gonna remove it? Also, so we have the thing about removing the node. We're not gonna actually remove it, but we're gonna change the pointer. We're gonna make the pointer the 4 here is pointing at 7, but we're gonna change it to point at 1. So this is the whole idea about removing the node. So but okay, so is this function to remove it? Oh, it's recursive. Okay, it's recursive. Okay, so we're gonna define it. After all this, so I have to define another function. Okay, so this so this has to be like that. I think I'm not doing it right. Okay, so right, how is that? So remove self.remove first node. Okay, I see. So I was gonna use the method of self.remove the first node, which is this. If self is head is not, then it's gonna return it. It is a empty linked list, and then it's gonna make a pointer current node. He's gonna iterate through the list. He's not gonna iterate. He's gonna see the next of it, and he's gonna link it. I'm just gonna define it in Python. Okay. Explain layout. Hey chat, how are you? How's your day? So, current if index else let's make this like that. So if it's index equals 0, then we're gonna remove it, else while current node is not none and position is turbo day, why? And position is lower than index minus 1. I think I'm not defining the index. So so this is will be position. Oh no, I'm gonna make this size. Okay, so size, position, size, will be size equals 0, and that will be size, and that will be size, and then what position is size. I think this is not. I don't know. So, hey, welcome to stream, man. Thank you. I'm waiting for you to calculate size, which is one while loop. No, I already calculated it. So this is it. Okay, I calculated it. It is like this. So current node. So as I said, the current node next will be the current node next dot next. We're just gonna point at the next of the next node. But the else is set. The else for what? So if the position, if we got to the position, so if no, when he complete all this, he's gonna just, when he complete his while, so the position is not in the size. So if current node is none, index minus 1, so this out of the loop, so I think there is no condition, so we're gonna just make it like this, and to have to return, I think. if head dot data or if health dot val. Okay, so if head dot val. Man, the linked list is so no, it can't be. No, it's only head. It's not the value. It's the head itself. So I think it's gonna be an error here also. Okay, so non-type object has no attribute next. What? So here I made current node equal head, so it will be it will have the same attribute, which is var and next. Why is it not do this? So let's put that here. Okay. The position value is okay. Okay. Yeah. Good, you're smart. I swear you're smart. So I don't have a position. Okay, so I don't have a position. So here I'm just gonna make position equal 0. Okay. Same thing. Okay. here current head, current node equal head. So this here equal head, and then the current node, why current node is not null, is gonna return this size. Just want to print this size to make sure everything is go up. Okay, so the sizes, I'm gonna make it int. So size equal end of this to make it 3. Yeah, I sign it here. So now the size is 3. Okay, position equals 0 if index. So here is not the index if position equals 0. So we're gonna remove the first node. Else while current node is not none, and no, once you traverse it, it become none. No, okay. So now you need to figure out why indexing, because it's not reaching else. Where I need to reassign it to head? Oh here. Okay. So okay. So I think here is good. No need sizes very slow and fast. Yeah. Okay. So just gonna make remove first nodes. That's already defined here. No, yes. Okay. Why it's not important this remove last node, but it has to know what is it head dot remove first node. Listen, pass self in the function. Self. Oh yeah. I think that'll go. No, we have to. Okay, def. No, we have to make head here, I think. Or current node. Function definition. It is already. So here I'm gonna make current node. No, the whole function is not defined. He's not. Why is not reading this? Self dot remove. That either didn't work. Okay, I'm writing it last and it is first. I'm just gonna check for it. So the whole definition, I copied the wrong one. So yeah. So if self head equal none, so we're gonna return the list and then self head equal self head dot next, and this is it. So it is height first, and this should work. Okay, so no parameters. Oh yeah, it's like the code is glued. Okay. So, it's gonna just check if they had equal none, so it's gonna return it, and then self head equal self head dot next. It's just a condition. So should I? Suppose I don't have a global parameter. Call it head. Yeah. So can I define this function in this function? I think I can. Or not. Okay. We're gonna just try it. No. This is full, man. No. The order is not gonna change anything. I'm looking like a fool here, man. So I'm gonna just I'll just make it here. So to get rid of the thing. So this is here and this is here. And you can get rid of that. Okay. So if head equal none. Okay. At least. Oh. So 3. What do you have to return? Have to return the sub. We just have to return it. How many code have you solved? I think I've done 50. I think 35. Your size is 3. No, it isn't about the size, but it's not returning anything, so the size is good actually. Do I have to return head? Or the output is not a list, or it is. Okay, I'm just gonna try it. So after all that, return head. So, okay. Why it is looking like this? So 1, 2, 3, 4, 7, 3, 4, 7. It's always removing the first element. So I think there is this condition here is. How do you know if you want to solve? يا بالطبيعة مرحبا بك أمين. أما تحب شي مثلا غدوة؟ تحب شي غدوة ولا نعش بعد غدوة؟ بالعكس مرحبا بك على الأخر. I said to him, you are very welcome, but if you want tomorrow or after it. I saw your message, okay. So, what were you thinking? Oh, there is a. This bot is not letting you. Why? Okay, I'm gonna solve it. I solved this issue. اوكي امين بدنا نبعث لك مسج بالطبيعة. بدنا نبعث لك بعد اللايف ستريم. So the idea is that he is deleting the first element. Okay, chat. It's 41 minutes, so I really gave up. I'm just gonna ask chat about it and see just my what is the man. Okay, so I'm just gonna. So I've been working lately on a ASP.NET project. If you want to see it, let me know. Solution. Why is you need to have longer live streams so you can give up less time. Yeah, I think, but man, I have to sleep. So the issue in your code lies in the handling of the if position. Yeah, I think. Why delete the first element instead of the middle condition? Position is right. So okay. Okay, I'm just gonna get rid of the first condition, which is here. Okay, just get rid of it. Oh, we're good. Okay, let's just submit it. Ah, man. Okay. Oh, so it has no. Ah. It has no next dot next. Why? No, I think it's not easy. Ah. Non-type has no attribute next. quite is working on those, and this not what. So I have I have one element. So I have to make a condition. So if head dot next equal null, uh, we're gonna just return head or none. Okay. We should be fine right now. So I should return none. Ah, man. The the thing is not working right now, so but I see that this case. What the fuck? Okay, so thank God. So it's not that bad, actually. It's not that bad. Okay, let's see what others did. Yeah, slow and fast. Okay, so we're gonna have two pointers, I think. Slow equal head, and fast equal the next of the next of the next of the head. While fast is not null and it's C++. Okay, and fast dot next. Yeah, okay. Give us link to buy this amazing keyboard. Okay. Let's go to this problem. You're making fun of me because I'm poor and I have a nine. It's $9. It's not even $9. It's a keyboard that I borrowed from a friend, so it's a free actually. So I think this problem is gonna be a lot more harder. Okay, so given the head of singly linked list, group other node with odd indices together, followed by the node with even indices. YouTube resolute that and chat. Nah, you're richer than me, man. Followed by the node with even indices and return to. The first node is considered odd and the second node is considered even. And so on. Then we're gonna start by odd and then even, so it's like 1 and 2. Okay, so note that the relative order and so on. You must solve the problem. Extra space. Okay. So the odd linked list is 1, 2, 3, 4, 5. The index of 1 is 1. The index of 3 is 3. The index of 5 is 5. So we're gonna group them. And then we're gonna group the even. Okay. So 1, 3, 5, and 7. We're gonna group those, and then we're gonna group those. Okay. So how are we gonna do it? Okay, let's say we have this 2, 3, 4, and 5. I hope it's not the fast and slow thing. I hope it's not, because I'm really not I didn't revise it actually. So this, okay. So I think we're gonna make another variable which is position. Okay, we're gonna start from this. The position will be we'll start by 0 or by 1. Okay, we'll start by 1. If the position, no. Hmm. It's really easy. Hmm. Okay. I think of changing the, no, not gonna change. Um, I think of 1 will be point to 3 and 3 will point to 5, but the 4 and the 2, how are we gonna put them? Or we can point to like that, 1, 3, 2. No. Okay. Okay. So I'm gonna link every even to a even, and in the last, which is null, we're gonna link it to the first to the first one. Oh, and I'm gonna link the also the the pair, the even, to itself, and after we we reach a null, we're gonna link it to the 2, and then okay. No, that's not the solution. I think it is that. Hey, Kate, I don't understand your emojis, man. Oh, you're typing. Okay, okay, gonna wait. Mm, but that will delete them. Pointing at another one will delete them. Or I can make a copy of it. Hmm. Um, slow on the first. Okay, I'm gonna watch a video about the slow and fast pointer, and I'm gonna later. So the 5 pattern equal.
Put -1. A brute force approach is to use a nested for loop to check the idea behind fast and slow pointers. Using this approach, you can check if a linked list contains a cycle. Start by placing both slow and fast pointers at the head of the linked list. Move the slow pointer one node at a time and the fast pointer two nodes at a time. If there is a cycle, they will eventually meet. This pattern can also find the middle node of a linked list in one pass. When the fast pointer reaches the end, the slow pointer will be at the middle of the linked list.
Yeah, I have to be like this smart Indian guy.
Get better at this
to,
pattern.
to make a YouTube video like this, man.
You can practice these lead code problems. Next pattern on the list is linked list in place reversal.
Oh, so he's not
They
given
will
the code.
eventually meet. This pattern can at a time and the fast pointer two nodes at a time. If there is a cycle, they will eventually meet. This pattern can also find the middle node of a linked list in one pass.
Oh no. Middle node of linked list in one pass. Ah. I really don't. I'm really. Oh. No. Hey. Hey, Kay. Why this bot is doing like this? I'm gonna. Okay, I'm gonna stop it. Okay, please type something to know that you're not out. Okay. Yeah, yeah. Um, um, so, okay, if you want to, after the video, we'll discuss about, but now, and you can use the voice on stream, I don't mind. Uh, it's already 57 minutes, so I think I'm just gonna work it with ChatGPT, or I'm gonna just understand by the video. But after the live, if you're there and you're still awake, you can teach me. You can teach me if you want. Okay, just gonna watch a YouTube video about, because the video is gonna be too long. Perfect, dude. Thank you.
Hello and welcome back to the Dragon Fan YouTube channel. Today we're solving 328 odd even linked list. Given the head of a singly linked list, group all nodes with odd indices together, followed by all the nodes with even indices, and return this reordered list. The first node is considered odd and the second node is considered even, and so on. Note that the relative order inside the even and odd groups should remain as it was in the input. You must solve this problem in big O of 1 extra space complexity and big O of n time complexity. So let's look at an example where we have 1, 2, 3, 4, 5, and we want to reorder it. So obviously the first element is considered odd. So this is an odd, this is an odd, and this is an odd. And then the evens are here and here. Luckily, they're also evens together, which should link to 5. And then we do the evens and 2. We're going to basically just do what we had, for example. So obviously, the first odd one is here. So we're going to have a pointer at the odd. We're basically just going to loop through the entirety of our linked list. And we're going to say, okay, we have 2 pointers for the odd and the even, and the odd, we don't care about this even anymore. So we want it to go to whatever the next value is in the list, which is the even one, but we want to skip it. So we want to go to the next odd. So we can rewrite as 1, 3.
This is it. Wrong question. It's 328. think this is it.
And now the odd pointer will be here, right? And then for the even, we can do the same, right? We don't care about the next value because that one's odd. We want to go to the next one, to this 4. So that means that our even is now what? Let me move this down, actually. Give some more space here. Okay, so now our even is 2 to 4. And this is the new even pointer. Oops, let's just do even. Okay, so now we can continue. And our odd pointer is now here. So let's now do the same thing. So we're going to skip here, and now the next one is 5. And we're going to do the same thing with the even. We're going to move the even, we're going to skip the next one because that's always going to be odd, and go to the next one, and that's going to be 6. So we have 2, 4, 6. And now the odd.
Okay, it's like I said. When I am in a node or odd number, I'm gonna skip the even, so it's gonna be next dot next. I'm gonna be like this. Okay.
Odd is now
I know,
at
but
5. But as you can see, there's actually nothing left, so we're done there. And same with the 6, there's nothing left for us to do. But now we have these two kind of disjoint.
He's gonna point to the 5 to the 2.
We have this, which is
So the
contained
5 to
in
the
our
2.
odd pointer, and we have this, which is contained in our even pointer. And what we actually need to do is just link the 5 here to the 2, and that way we'll get 1 to 3 to 5 to 6. To 2 to 4 to 6. So that's essentially the algorithm, right? We're going to have our odd pointer. We're going to skip 2 nodes to basically link the next, and it can basically continue this into the end of our odd list to the start of the even list.
My approach is good. My approach is totally correct.
And that is our final solution. And we'll have done this all in place, and obviously with a big O of n runtime, because we just need to prop in the code editor. Let's type this up. The head is actually list.
So if not head,
is equal to the pointer, which makes sense because the next because odd will always come before even. So is we want to the current odd, the next value, that value's next value.
Okay.
So value after even dot next. So we can need to just move the pointer up. So the new odd becomes odd dot next, which is now what was previously before odd dot next dot next. So we've now moved it up. We need to do the same thing for the evens. So we're going to say the next even value is going to equal to even dot next dot next. Pretty straightforward. And then we just need to move the even up forward, right? So we're going to say equals even dot next, right? Okay, cool. So that moves up the even, and we're good to go. So basically this loop is going to run, and
but then we have to link the last odd to the first even.
So now what we want to do is we simply want to connect the odd, the tail of the odds with the head of the evens, right? So we're going to say odd dot next is going to equal to the even head, which we defined earlier. So this is going to be the head of the evens, and we simply link them to basically put all of the evens at the end of the odds. And then all we need to do at this point is just return the head. It hasn't changed, and remember, head is just that first odd value. So when we run this, we can see that it looks good.
So as I said, we're gonna make 2 pointers here. I think I made a mistake about using 1 pointer, but the idea, we're gonna make 2 pointers, one for the odd and the second is for the even. We're gonna connect the odd, each one of them, with the next dot next, which is the next odd number, and then and the even, like the same, and then we connect the tail of the odd with the head of the even. So this is it. The approach is pretty much correct, but in code I didn't write it in code, so it's now 1 hour 5 minutes. I think this is the end of stream. This is the end of video. Thank you everyone for watching. Don't forget to follow me on my social media account. Don't forget to like this video, to follow me on YouTube. Hope this channel, this video benefited you, and hopefully I will see you tomorrow. So tomorrow, like this, it's gonna be 10 p.m. The stream or the video will gonna be 10 p.m. like any other day. So be there and see you tomorrow.